Hello everyone, we are Unit 11 Lesson 9, our review of sine and cosine functions. Those are the only ones that we will need thus far. So we have these equations, a sine bx plus c and a cosine bx plus c. A is the amplitude. Remember I discussed it yesterday in class with a lot of you that it's the absolute value of A is the amplitude. The midline is the C, the B is the frequency, and P is the period. Now remember I use period, oh, what happened there? Period is 2 pi over B. So the period is 2 pi over B is the formula I use. If you use BP equals 2 pi, it's okay. You just have to plug in, and it won't be the exact way I do it in class, but you still will arrive at the same answer. So we're going to look at some application of these graphs. So exercise 1, we're talking about tides in a particular bay, modeled with the equation. D, it's a cosine, so it either starts at the highest point or the lowest point. So T represents the number of hours since high tide, D is the depth of the water, and since it is D equals A cosine BT plus C, the D is your Y, so that's the depth. The maximum depth of the water is 36, so the highest I can have is 36 feet. The minimum is 22. Now, it's okay if it's not spaced out exactly. When we do it on quizzes, tests, and Regents exams, you will have a grid so that you can count exactly the right spaces. And high tide hits every 12 hours. Okay, so I'm getting a little ahead of myself because I know they want 2 full periods. So I'm going to put this down here as 12. Because that's when we're going to have the high tide. It starts and then ends. So it's one complete curve. So on the axis, sketch a graph of the scenario for 2 full periods. Label the points on the curve that represent high and low tide. Okay, so we are talking about the number of hours since high tide. So we know it has to start up here at the 36 for the high tide. Now, what I like to find too is the midline. So remember the midline is 36 plus 22 divided by 2. That will give you your midline. So we have 58 divided by 2, which gives me 29. So right about here is 29. So you can check that. So 29 up to 36, okay, is 7. 29 down to 22 is also 7. Okay, so this should be a dotted line. Okay, so there's your midline. So 12 is one complete curve. So it's going to be approximately, again, starting at the 36, coming down to the midline, going to the min, going back up to the midline, and going to the max at 12. Now, it wants 2 curves, so that should be 24 hours. So I'm back down to the mid, the lowest, back to the mid, and back to the highest. So the curve looks something, and we understand it's not going to be perfect. So it looks something like that. So, and then they want you to determine the values A, B, and C, so I kind of already did that. So A, remember, is your amplitude, so A is 7, and it's positive because it starts at the highest point. My C is the midline, so the midline is 29. Now, in order to find your B, so remember, period is 2 pi over B. And we got the period that was 12. So 12 equals 2 pi over B. 12b equals 2 pi. So then B is going to be 2 pi divided by 12, which is pi over 6. And that is what your B is. If you need to rewind it, play it again, rewind it and play it again. Not a problem. Now it says that this is a little add-on. It says that tanker boats cannot be in the bay when the depth of the water is less than or equal to 25 feet. So set up an inequality and solve it graphically to determine the points in time t over the interval which the tankers cannot be in the bay. And it says round all to the nearest tenth of an hour. So at less than 25 feet. So here's your 25. This is the line they're talking about right here. So we have 1, 2, 3, 4 points we have to find. So I'm going to go to the calculator and sketch this. Oh, I couldn't snap. There it is. Okay. So here's my first equation that I put in the calculator. just make sure in the calculator you have to use X's and Y's. So they had a T in the original one, so we made the T an X, okay, like you can see there. And then we're going to enter it, and you can clearly see it's not on the grid. So that's okay, it's not on the grid, we'll have to zoom out. So I'm also going to tab it and put the other one down, which was 25. So y equals 25, and enter. Okay, and then what I did is I zoomed out to make sure that I could see the graph. So I did the menu and then zoom. And what we want to do is we want to find these 4 points. So this shows a lot more than I need to see. So what we're looking for are the first 4. So 1, 2, 3, 4. And go to menu, analyze graph, and you want an intersection, which is 4. So my lower bound is here, my upper bound is here. So there's the first one, 4.16. And they want it to the nearest tenth, so it's 4.2. To find the next one, menu, analyze graph, intersection again. Here's my lower bound, here's my upper bound. And then I think you can take it, yep, there you go, move it down. So 7.8, okay? And then you can find the other 2. So when we go back to here, we want to find when the tankers cannot be in the bay. So it's 4.2 less than or equal to T, less than or equal to 7.8. And the other 2 would have been 16.2 less than or equal to T, less than or equal to 19.8. And you would have found those the same way I found the first 2. Now we have another equation, exercise 2. The height of the yo-yo above the ground can be modeled using the equation, which is cosine again. We have a lot of cosines here. Determine the maximum and min heights. So this isn't too bad. Max min, you have your midline, which is 2.25. Then we add to it the 1.75. 2.25 minus 1.75, because that's going to give you your max and min using your midline and your amplitude. So we do this top one, we get 4, and what are we talking about? It's feet, 4 feet, and the other one is 0.5 feet. So that's your max and min heights. How much time does it take for the yo-yo to return to its maximum height? So that's where we're talking about the b term. So the b is pi. So the period is 2 pi over b, which the period is just 2. So talking about seconds, so it's 2 seconds. So that's just application of your formulas. Now we have a Ferris wheel. Person gets on the ground at the lowest point, which is 5 feet above the ground. The highest point is 130 feet above the ground. Another cosine. So we'll definitely do some sines in class. So this is 5 feet. This is 130 feet. I just know that because he gets on. It's 5 feet, and the highest point is 130. The amount of time it takes to do one full rotation is 8 minutes. So if I have 8 minutes for one full rotation, I think I only want one. So there's your 8 minutes right there. Person's vertical height can be modeled by the function, and it's an equation. Cosine, sketch the graphs. The person's vertical position for one cycle, determine the values of A, B, and C. So we have our 8, and what we like to do is we'd like to find, there's your 4, there's your 6, there's your 2. So we want to have a starting point and then 4 others. So you have a total of 5 points you can sketch your curve. Now you're talking about getting on a Ferris wheel. So the most logical place to start is right here. Okay, that's where you're going to start with the Ferris wheel. Now in the middle here is your midline. So I'll just draw it in, and then we'll figure it out after exact value of the midline. So we have 5, and then we go to the midline, then we go to the highest, back down to the midline, and then back down to the lowest. So this is your little Ferris wheel ride. Okay. Now you want to find all your values. So the first one I would start with is I would start with C. So C is 130 plus 5 divided by 2, because that is your midline. So I did 130 plus 5 divided by 2, and I got 67.5. That's your C. Now to find your A, you can do 130 minus 67.5 because you want to find this distance right here, which is 62.5. And it would work the same if you did 67.5 minus 5 and got your 62.5. Now the B, you want to find the B, it's just like we did in the previous one. Period is 2 pi over B. We know the period is 8. So we have 8 equals 2 pi over B. Let me lower this a little bit. And we cross multiply. We have 8b equals 2 pi. Divide by 8. And I get pi over 4. And that is my B, is pi over 4. So they just wanted to determine the values of A, B, and C. And there you have it. Oh, so if I wanted to draw this equation, they don't ask for it, but if you wanted to show me the equation, it would be y equals, it would be negative because it starts at the bottom. So negative A, which is 62.5, cosine B, which is pi over 4t, because you got to use the variables they give you, plus C, which is, I can't squeeze it in, 67.5. And that would be the equation. Okay? Now the last one, possible hours of daylight in a given day is a function of the day of the year. In Poughkeepsie, New York, the minimum hours of daylight is equal to 9 hours. The maximum is 15. If the hours of daylight can be modeled using a sinusoidal equation, what's the equation's amplitude? So in order to find the equation's amplitude, they tell me that the highest is 15, the lowest is 9. Okay, so if you need to do midline, you can do the midline. 15 plus 9 divided by 2. So I find that midline. I get 24 divided by 2. I get 12. So my midline is 12. So the amplitude is the difference here or here, which gives you 3, and that is choice 3. Okay? So that's it for lesson 9. That pretty much wraps everything up. I'm going to have a worksheet to do some more practice problems, and we'll have a short quiz on Tuesday. So make sure we're ready for it. All right. We will see you in class. See ya.